So today we're going to be doing the Confidence in Measurement Lab, Lab 1.3. We're going to get started. Thanks. So the first step for this lab is to measure the mass of a 250 milliliter beaker with my triple beam balance. The first thing I'm going to do is I'm going to use my heaviest weight at 200 at sink. So I'm going to come back. Then I will come over here. It sank at 50, so I'm going to keep coming back. And it finally sank at the 10. And then I'm going to come over. Starting to float. Let's see what that line does. It's still floating a little bit, so once it steadies out a little bit, it'll be a little bit easier to see. It seems a little bit sunk, so I'm going to come over one. And it should even out just about right. Okay, so this is your measurement here. Okay, so this should be a pretty clear image of the numbers on my triple beam balance. Make sure that you are as accurate as possible. So record all numbers that you possibly can. Your second step is to measure the volume of the water in your beaker. So I'm going to pour the water in. I just colored the water. So with your best approximation, try to estimate the volume of the water in the beaker. Notice how I'm at the 50 line and there's one line in between the 50 and the 100. So ask yourself what each dash represents. Okay. So the lab says water is unique in that its volume in milliliters is the same as its mass in grams. Based on the amount of water you have measured out on your beaker, the volume that you measured on your beaker, write in the table what you predict the mass of the water will be in grams. Now it's time to measure and record the mass of the beaker and the water together. So I'm going to put it on my triple beam. I'm going to do the same thing. Start my hundreds. Too heavy there. Come down. Barrel. Ooh. Will it make it? I don't know. Let's see where it lands at 50. If it's too light, then that's actually perfect. If it's too heavy, then I have to worry about the 40s. All right, I'm going to say that is about right. And because the numbers are where they are at, again, record all numbers present. Okay, be as accurate as you possibly can. So now we're going to have to do a little bit of a little bit of math. So the mass of what we just did is the beaker plus water, right? That's what we just did. So now we just need to get the mass of just the water. Okay, so go ahead and do that math and do it here. And then you're going to do the percent error. You want to do that using this formula, right? So it's going to be your predicted value, which is what you recorded here, minus the actual value, which is what you did here, put that in parentheses over the actual value times 100. Now it says record the smallest increment of measurements marked. So that is on your beaker. What is the smallest increment? What does it go up by on your beaker? We're now on to page 12, measuring volume with a graduated cylinder. So I'm going to go ahead and get the mass of my graduated cylinder. I don't think it's going to be 100, but just in case. Alright, it didn't do that. Let's go to 70. Alright. Going all the way to 90. So, I want to go back to the 80 because it is sinking just barely. So I'm going to go real slow here because it had barely sunk at 90, so maybe I need to go a little bit faster. It's finally coming down a little bit, but not fast enough, so let's try. Notice I didn't use my hundredths place, and I'm at my, but I do have my other weights going. So let me try it there and see where we're at. A little bit too light, so I'm going to come back over a little bit. It's a lot of waiting in lab, but that's okay. You're getting the lab experience, a genuine experience. This still seems a little bit light, so I'm going to come over to, try to control it a little bit so that it doesn't swing so much. Then we won't have to wait as long. Okay, so now it says pour the water from the beaker into the graduated cylinder. Record the volume using all digits you can possibly record with confidence. So I'm going to go ahead and pour it slowly so that you can see it clearly. Okay, so I'm going to wait for the bubbles to set. Get the bubbles out there. But notice how notice the increments between here and here, okay? And do your best approximation of what that should be. So again, what you're going to be doing, this is a more zoomed in, clearer image of the water in the graduated cylinder so that you get a hint since it's is a little bit dark, okay? This line is the 30 line. And then this line is the 35 line, and you should be able to see the dashes above that solid line around. Again, you want to be as precise as possible, so record all the numbers that you can. Estimating is allowed. I'm now taking the mass of my graduated cylinder plus water, bringing it down to 100, and it still floats. 200 is too heavy. Bringing it over here. And bringing it back down a little bit at a time. Let's see where we're at. Here's a zoomed in image of the mass that I got on the triple beam balance of the water plus the graduated cylinder. So now you need to do some math to get the actual mass of the water, and use the exact same calculations you did on your measuring with volume of beaker on the page before to calculate the percent error. So now you want to record the smallest increment of measurement marked on the graduated cylinder. So you can see that. Let me show you here. Okay, so what is the smallest increment on this graduated cylinder? Okay. So your last step is to congregate your data. So you're going to take your information from here, and from here, and you're going to copy that, it's your own work, from your data tables over here. And the goal is to talk about which one was more accurate, your beaker or your cylinder, and why you believe that, and what digits you should have recorded, and what digits may have been unnecessary. So, thank you, and good luck.